So there's a question on chapter 4 dealing with setting up a system. And it's that chemist question. There's a chemist who needs like 5% solution of this and a 7% solution of this, and you end up with an acid that is this percent of this much. All you gotta do is break it into the pieces that it's telling you. And you really need to rename those solutions either acid A or acid B, or somehow name them. So I'm gonna set up a similar problem. If I am a chemical engineer and I'm trying to produce, let's say I want to produce 100 milliliters of an acid at 7% is its acidity rate. And what I have is a solution A that is 5% and a solution B that is 10%. So I don't know how much do I have to mix of them to get 100 milliliters of a 7% solution. Well, what I know is since my total solution is 100 milliliters, however much of A that I use plus however much of B that I use has to equal 100 milliliters. Or in your case, 75. So that's one equation that I set up because I know that my two solutions have to equal 100. The next thing that I know is I'm going to use some quantity of A, and it's only 5% acid. So I've got 5% of acid in however much I use of A, and I've got 10% of acid in however much I use of B, and those have to equal a 7% solution, and I know that that has 100 milliliters. And really, I would say C here, but that's quantity, and I know the quantity of my final solution. So instead of putting C, I just go ahead and put 100 mil. From there, I would use substitution. Isolate one of your variables here, sub in, and then solve for the other variable, sub back in, finish it that way. That makes sense now? I think you can ride that out. Cool. Any other questions from chapter 4?
So you just, where'd you get
Do you want me to finish this?
A plus B for that?
Because so if you look at your chapter 4 test, there's a problem on the back, the chemist one, and it ends up telling us that we need 75 milliliters of the solution. I made my situation say we need 100 milliliters. So I know that the two solutions I'm using that I nicknamed solution A and solution B, those are going to add up to 100. Does that make sense? That's where I got that
equation.
equation.
Find out that they were 5 and 10 acidic,
The problem tells you,
Oh.
yeah. So I made up different numbers.
And you just have to find out how much.
So from here, I could say that A is 100 minus B. If I subtract B from both sides,
It's asking you to make a system for it, right?
this is I have two equations. That's a system of equations. Anytime you have more than one, it's a system. Yes, with me? Anytime I have more than one equation, it turns into a system
So
of
it's asking
equations,
you to make 2 equations?
which is what we have here. We know that my solution A and solution B have to add up to a certain amount of liquid. Then I know that with 5% acid in solution A, whatever quantity I use, 10% in quantity B has to give me 100 milliliters of 7% solution. Other questions? All right, so I'm gonna, yeah.
It sounds stupid, but why can't 0.07 in the parentheses?
So this was our milliliters, and this is our acid percentage.
Oh.
So if I want to talk about how much acid is in that, it's 7% of the whole solution.
Okay. So in ours it says
75
and 5% is 50.05 and then 75.
It has
Yep.
3 values though.
But you know how much of your final solution you make. So this is solution C, but you know how much of it there is. So for your problem, you have, what's your first solution's percentage, like 7?
2.
2%. So you would have a 2% of solution A. How much is your B?
8.
8%. 8% of solution B, and we don't know how much, that will give us 75 milliliters at what percentage?
With 5%.
Yeah, they want us to end at 5% acid. So 5% of my 75 milliliters.
How can there be, because that would be 10%. I mean,
No.
10%.
As I add 8% with 2%, it pulls down my 8% acid and pulls up my 2% because you're mixing, right? So if you have water and gas and you start to mix them together, they don't mix well because their viscosities are different. But as I pour water into the gas, my gas becomes watered down. Or as I pour gas into the water, my water becomes gassed up, or whatever you want to say. So by mixing these together, you're going to get a solution that has a percentage somewhere in the middle. The more I use a B, the higher it will be. I can never get to 8% if I'm using any solution A.
Okay.
But if I use all solution B, then I get 8%. But as soon as I start to mix in A, it gets lower and lower and lower percentage. So I'm going to go let the people in the library know, but we are going to stop with our full group work here for today. Next week, we will dive in at chapter 5, taking questions and concerns and everything. So I'm going to be expecting assessments to be coming in. I'm going to, unless people have one-on-one questions for me, I'm going to grade everything that I have and get it back to you guys. So if you so choose, you can leave at this point. My advice would be get some work done while you're in like the school setting. Depending on what you guys decide, I can turn on like some chill piano music or study music, whatever. But at this point, that's the end of everything, like full group today. So we'll start at chapter 5 and see how far we get next week. Hopefully we'll cover another 2 or 3 chapters of questions. Anything else for me? Cool. Thank you guys very much.